To calculate the full load current, or FLC, for single-phase fractional horsepower motors, you can use NEC Table 430.248. This table provides FLC values for various motor horsepower ratings. However, if the exact horsepower rating isn't listed, you will need to interpolate between the two nearest values. The standard procedure to calculate the FLC for fractional horsepower motors from NEC Table 430.248 is as follows. Firstly, identify the two nearest horsepower values from the table. Secondly, calculate the ratio between the actual horsepower and the smaller of the two values. Thirdly, interpolate the FLC using the following formula: FLC equals FLC of smaller horsepower plus ratio multiplied by the quantity of FLC of larger horsepower minus FLC of smaller horsepower. Let's look at an example for a 1/20th horsepower motor. The nearest horsepower values from the table are 1/15th horsepower and 1/12th horsepower. The ratio equals 1/20th horsepower divided by 1/15th horsepower, which equals 0.833. FLC equals 1.7 amps plus the quantity of 0.833 multiplied by the quantity of 2.0 amps minus 1.7 amps, which equals 1.86 amps. The table of full load currents for single-phase fractional horsepower motors is as follows: motor horsepower and full load current in amps. For a 1/20th horsepower motor, the full load current is 1.3 amps. For a 1/15th horsepower motor, the full load current is 1.7 amps. For a 1/12th horsepower motor, the full load current is 2.0 amps. For a 1/10th horsepower motor, the full load current is 2.4 amps. For a 1/8th horsepower motor, the full load current is 3.0 amps. For a 1/6 horsepower motor, the full load current is 3.6 amps. For a 1/4 horsepower motor, the full load current is 4.4 amps. For a 1/3 horsepower motor, the full load current is 5.2 amps. For a 1/2 horsepower motor, the full load current is 6.8 amps. The interpolated value should be rounded out to the nearest standard current rating. If you have a graph available, you can use a straight line interpolation to find the FLC more accurately. It is also important to consult the most recent version of the National Electrical Code, or NEC, for the most up-to-date standards and tables. Also keep in mind that motor manufacturers often provide the FLC on the motor nameplate, which should always take precedence over any calculated or table-derived values. Always prioritize safety and consult with a qualified electrician when working with electrical systems. The FLC calculation is crucial for proper circuit protection, conductor sizing, and overload protection for the motor.